Okay, so we are going to start with a review of open proof writing. That means that we're trying to prove that generic shapes that don't have specific numerical side lengths or angle measures are congruent to each other. So in this drawing to the right, we have triangle ABC and its isosceles with AB being congruent to AC. We also know that CD is right here, that it bisects ACB. So we know that these two little guys are congruent. And we also know that BE bisects ABC. So these two guys are congruent. We also by default know that all four of these are congruent because if this is isosceles, then this entire angle is equal to this entire angle. Now that's a property that flows forth from the definition of an isosceles triangle, and we'll talk about that more once we get into our proof writing. We also are told that CD intersects BE at point F, so these two lines are intersecting here. I want you to study the figure. I want you to find as many congruent triangles as possible, and I want you to tell me how you know they're congruent, by angle, side angle, side angle, side. What theorems would tell you that they're congruent? Now to do that, you would need to know or be refreshed on your triangle congruence theorem. So this is one of the handouts that I'm passing out in class. It refreshes your memory on the different theorems that tell you how a triangle is congruent. There's side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. So you would have that handy. It also goes into those that do not work, which we'll talk about a little bit more today. And then it has some similar triangle properties, which we will go over on Thursday. So you would have that handy. The other handout that I want to give to you has common properties. Now I've written a couple more in here because I actually created an updated one for you. So let's switch this one out really quickly. The one that you're gonna have, and you can have this handy along with the definitions of quadrilaterals for our first test that's next Thursday, not this Thursday, next Thursday. This is 26 properties that I expect you to be familiar with and be able to apply. They're ones you've seen for the last several years of your math existence, but these particular properties are ones that you would need to be able to use to write the proofs that we'll be looking at in this class. Okay, so you have those. Now, I want you to study this figure and figure out how many different triangles you believe are congruent. Okay, so let's say that you studied this for a while, and I'm just going to dissect this a little bit, but I'm going to take out this triangle and then this triangle. So I'm taking out B, A, E. I know that that's congruent to, these are not drawn to scale, A, D, C. How? A is equal to A by reflexive property. I know that B is going to be congruent to C because A, it's isosceles and they're being bisected. So those little angles are congruent. And then because this is isosceles, these two sides by the definition of an isosceles triangle. So by angle, side, angle, I know that triangle AEB is congruent to triangle ADC. Okay, so that's by angle, side, angle. Okay, how about another set? So we just did this one and we did that one, but you also know that this little guy and that little guy are congruent. So let's go ahead and draw those over here. So that's going to be BDC and CEB. Now, since we just proved that these two guys are congruent, we know that DC and EB are congruent by corresponding parts of congruent triangles are congruent. So we know that those two would be congruent to each other. We also know that this side, which overlaps, BC, is congruent to each other. What else do we know here? Well, we know that this little angle is congruent to that little angle, because of the angle bisector theorem that we talked about, because of the angle bisector, and by substitution, given that we know that all four of these different ones equal each other. So that's going to be side angle side. Okay, and then lastly, these triangles are equal to each other. So they're the ones that are kind of connected like this. Again, this is not drawn to scale. So we have a B, a D, an F, an E, and a C. These little guys are congruent because vertical angles are congruent. We also know that these two sides are congruent because we just proved these other triangles are congruent. So by corresponding parts of congruent triangles, those little guys are congruent. And finally, we've already proven that these angles are congruent. So now what are we looking at? We're looking at angle side angle for these two guys. I should write the triangles that are actually congruent to each other. So that's going to be triangle DFB is congruent to triangle EFC, and then this one over here would be triangle BDC is congruent to triangle CEB. Okay, we've informally done some proofs here. We know what theorems we want to use. We know that we have three different sets of triangles that are congruent to each other. We're now going to write a proof. I asked you just to write a proof for one of them, but we're going to be overachievers, and we're going to consolidate and write a proof for all three of them. Because why not? And we're going to do that in the next video.